Hello, my viewers and dear learners. This is your DK Misra sir. I welcome you to this session. Good morning, good afternoon, good evening, whatever you connected with. So, today's topic I have given circle, right? As you know, my dear learners, the circle, a circle is a collection of all points in a plane which are at fixed distance from a fixed point in the plane, right? This is your circle and this is your point where it's all the points, right? Am I right? Now, do you know very well the study of circles goes back beyond history. The invention of wheel was fundamental discovery of the properties of a circle, right? Now today we will discuss in this session theorem on circle, right? Let's see. Concept of tangent at any point of the circle. A circle has important element such as chord, secant, tangent, right? Now take this statement. This is theorem. A tangent at any point of a circle is perpendicular to the radius through the point of contact. You see by this figure you are understand these things. Now in the above figure O is the center of a circle and line L, this line L is the tangent and P, here is the P, is point of contact. Now let's see proof. It is given that O is the center of the circle, L is the tangent of this circle, and P is the point of contact. Let us assume L is not perpendicular to the radius of the circle. Now let's see. In this case, let us draw perpendicular OA to tangent. You see here, this one. This one you see, right? Now, thus point A is distinct from point P. Here is the P. Let B any point on tangent such that BAP is a line and BA equal to AP. This one and this one, right? Now, in triangle OAB, in triangle OAB, you see here, and triangle OAP, OA, OAB, and OPA. We have OA equal to OA. It is a common in both triangle, and angle OAB equal to OAP because OA perpendicular to tangent L. By construction, BA equal to AP, right? So the triangle OAB congruent to triangle OAP. So by simplicity we can say congruent part of congruent triangle. The CPCT full form congruent part of, no, corresponding part of the congruent triangle, right? Not congruent part of that, corresponding part of a congruent triangle. So that's why we can say that OB equal to OP. OB is a side and OP is the side of that. Since OB and O equal to OP, Point B lies on the circle, also point different from point P. Thus, tangent L touches the circle at two distinct points, right? This contradiction here, what you see here? This contradicts the definition of tangent, right? Hence, our assumption is wrong. Therefore, tangent L perpendicular to OP. It is proved. This also the converse of this theorem is also true, which state that what the line perpendicular to the radius of a circle at its outer end is tangent to the circle. This above theorem have to indicate it is converse for the theorem. Now proof. O is the center of the circle. Again you write, right? O is the circle, OP is the radius, L be the line perpendicular to OP, such as it passed through point P on the circle. Let's see on where. Let's see here. It's passing through, and now also let A be any point. Again you let A point on L. This is L, distinct from P. It is distinct from P. From the figure, it can be observed that triangle OAP is a right angle triangle. This is forming 90 degree. That's why the triangle OAP is a right angle triangle. Now OA become hypotenuse. Right? It is a figure indicate us that we recall the Pythagoras. OA is a hypotenuse for triangle OAP. Very good. OA greater than OP. OP is the radius, but A is the outside of the circle on line L. OA is not radius, right? Point A does not lie on the circle, obviously by the figure. Therefore, no point of line L other than P lies on the circle. Without there, we have to plot it P on here and to indicating that except P, no one points on the circle. Now, P is only point common to the circle and line L. Line L is a tangent to the circle at point P, hence proved. Let us now solve some examples related to the tangent of the circle. Let's see, first example. Draw a circle with center O and two lines such that one is a tangent and other is a secant. This is a secant and this is a what? Tangent. Am I right? This is a tangent. Now, the figure can be drawn as follows, as per the statement given here, right? Like this, we can draw the figure. Now, here, AB is a secant which intersect the circle at two distinct points, C and D. You see here, right? This here. Okay, good. And XY is a tangent whose point of contact with the circle is P. You see here. This is a secant line AB. AB touching the points on circle C and D and tangent touching a point of the circle. Clear? Which of the following statements are correct? There can be only one tangent at a point on the circle and diameter is also a secant of the circle. Right. See, first question answer correct and second is incorrect. Right? Diameter no. Next third example, a line XY is a tangent you see here a line xy is a tangent of the circle with center O and radius 6 cm. The point of contact is P and Q is any point on the circle. You see by this figure. The point of contact P and Q is any point on the tangent xy. You can take xy here. And if OQ equal to 10 centimeter, then what is the length of PQ? Right? The figure can be drawn like this. We know that the radius through the point of contact is perpendicular to the tangent. This statement is required to know. Now, OP perpendicular to OP perpendicular to XY, which XY is a tangent. Using Pythagoras theorem in right angle triangle OPQ, we obtained OQ square. Clear? You know, Pythagoras have given his statement about right angle triangle and put the relation here. OP square plus OPQ square. PQ square equal to OQ square minus OP square. And PQ square equal to 10 square minus 6 square. 10 square means 100, 6 square 36, right? And here we can see PQ square equal to 64. When you do this one, PQ square, write this one 64. Now you can get 8 centimeter. The length of the PQ is 8 centimeter. Like this we can solve it. Now the next example, you see here two tangent xy. We have taken two tangent here, xy and PQ. Are drawn at the end of a diameter AB of the circle. This is a diameter with center O, so that XY parallel to PQ solution, right? The figure can be drawn like this one, and XY is a tangent at A and OA is the radius. Very good. We know that the radius through the point of contact is perpendicular to the tangent. This line is very important to keep in mind, my dear learners. XY perpendicular to OA, XY perpendicular to AB, similarly PQ perpendicular to AB. Now the lines perpendicular to the same line are parallel. From equation 1 2, we obtained XY parallel to PQ, hence proved, right? Now this is a end of the session. In the next session we will meet again. Have a nice day. Thank you.